Yo, this Coach Ray back at it with another YouTube video. This one's on solving quadratics with the quadratic formula. One of my favorite sets of notes. So without further ado, here we go. First thing in blue, standard form. It's exactly what it sounds like. It means that it's standard to write quadratics in that form. 99% of the time when you see a quadratic equation, it'll be written in that form. If it's not, you've got to move stuff around so that it is in that form. Okay? So this is very, very normal. You're going to start seeing this a lot. Normally, A, B, and C are numbers. Okay? So it normally says something like 2x squared plus 3x plus 4 equals 0. All right? So A, B, and C are normally numbers. And something super, super crazy happened. I love explaining it this way because it just baffles my mind. I worry that I'm going to mess up dates and names because I didn't look up exactly who did this. I believe Pythagoras found this formula, which is crazy. Pythagoras was an ancient Greek who wore robes and sandals, and they had like a long beard, and they definitely didn't have computers yet. In fact, I think at that time they were taking sticks and writing in the sand to do a lot of their math. And if the wind blew, then their math disappeared. But this guy figured out that if you take those three numbers, A, B, and C, whatever those numbers are, in the quadratic equation, and put them in this formula, it always, no matter what, spits out the answers to that problem. Real answers, imaginary answers, every single problem can be solved using the quadratic formula. Okay? So that's all we're doing. We're identifying what A, B, and C is. We're plugging them into a formula, and we simplify, and we get our answers to that quadratic equation. And there's usually two. Okay? All right, so we're using blue and red a lot. This green stuff right here, I'm going to talk more about kind of as we're doing the problems. Here's what I want to mention right now as far as the green stuff is concerned. This square root of b squared minus 4ac is part of the quadratic formula. See, it's this upper right corner. That part of the quadratic formula has a name, and it's called the discriminant. Okay? The discriminant can be used to figure out how many solutions there's going to be. I always thought this was weird because how I figured out how many solutions there was going to be was just by doing the problem. If I did the problem and got two answers, then I knew there was two solutions. If I did the problem and got one answer, I knew there was one solution. And if I got two imaginary answers, then I knew there were no real solutions. Okay? But I'll talk a little bit more about the discriminant later. I'll show you how it works. All right, let's go straight to example 1. First thing I want you to notice about example 1 is it is not in standard form. See? You see? Standard form would be the x squared's in front, the x is in the middle, the constant's in the back. So we need to move things around to make it into standard form. Okay, head up. All right, so I could take negative 6x, move it over here, put it in the middle, and boom, in one step it'd be in standard form. I'm going to move the negative 3x squared and the 2 to the left, just because I want my 3x squared to end up positive when I cross the equal sign there. Okay, either way you get the same answer, but I'm going to do it this way. Plus 3x squared on both sides. So now I've got positive 3x squared minus 6x equals 2. Notice the 3x squared and the negative 6x, I did not combine them because they're not like terms. They've got different exponents, so I cannot combine them. All right, I'm almost in standard form. The only thing is it should be equals 0 in the back, and I need my constant over here. So I'm going to do minus 2 on both sides. So now I've got 3x squared minus 6x minus 2 equals 0. Now I'm in standard form. So far so good. Just moving stuff around so we're in standard form. Now that we're in standard form, I can see what A, B, and C are. A is the coefficient in front of x squared, that's a 3. B is the coefficient in front of x, that's a negative 6. C is the constant, that's negative 2. Okay, notice it's not, A is not 3x squared, it's just the coefficient, it's just the number, 3. Okay, let's plug them all into the formula. You can see the formula in your notes up above. I've got it memorized, so I'm going to just start plugging in. I've got x equals, here's one of the tricky things about the quadratic formula. It starts with negative b. Okay, it starts upper left corner, starts with negative b. B is already a negative number. You see that? Negative 6. So it would technically be negative 6, which would turn it back to positive 6. If it were a positive number for b, you would switch it to negative. All right, so I'm going to keep going. We got a plus minus symbol in there. We got a big old square root with a bunch of stuff in it. B squared minus 4 times 3 times negative 2 all over 2 times 3. For as complicated as that board looks right now, all I did was identify what A is, what B is, what C is, and substitute all those numbers into the quadratic formula. Now I just got to simplify. And actually, I'm going to pause on my simplifying. I'm going to just look at the discriminant real quick. Remember, the discriminant is just this square root up here. And I'm going to just kind of do this in my head. Negative 6 squared is going to be 36. This part, negative 4 times 3 is negative 12. Negative 12 times negative 2 is positive 24. So I've got 36 plus 24. It's going to be 60. So if I scroll up here, okay, 60 is obviously bigger than 0. So I'm going to have 2 real solutions to this problem. I would also find that out if I just kept working and got 2 real solutions as my answer. But that's what the discriminant will do for you. Okay? So I know there's going to be 2 real solutions. Now let me get back to simplifying. Will you scroll, please? Thank you. All right. Let me pause this. All right. Let's get back to simplifying this. Okay, so let's start simplifying. X equals, I've got 6 plus or minus. We already talked about this whole square root turned into the square root of 60. Again, on the bottom, I got 2 times 3 is 6. All right, square root of 60. Perfect square? No. What do we do what do we need to check if it's not a perfect square? See if it'll simplify. Okay, and it does. I can break the square root of 60 into 4 times 15. 4 times 15, which means square root of 4 is going to turn into the whole number 2. And then square root of 15 is going to stay like that over 6. The one annoying thing about these problems is, in this green line, it kind of felt like we were done. We did a bunch of math, okay? But you have to recognize that your square root of 60 will simplify. And now, in the black line, hopefully you recognize that there's going to be some reducing as well, so we're still not done. Okay, don't forget, this is how I do problems like this. I think it's so much easier to reduce if I break it into 2 problems and just reduce each one individually. So now I got x equals 1 plus or minus. This is from our square roots lesson last week. Stuff inside the house can't mess with stuff outside the house, right? But 2 and 6 are both outside the house. They can both reduce by 2. So now I've got square root of 15 over 3. Okay, and I'll answer questions in a second. I just want to point out, Alex, we're really going to have to check to see how we enter step 1 Alex, and I don't fully know the answer. Okay, when we start doing the assignment, you guys will have to let me know, okay, Alex lets us plug it in like this, not like this, but I just want you to see this is the most simplified answer we can come up with. All right, that is going to be the end of this video because example 2 is going to take a little bit longer. It's been real good video, everybody. Deuces.